12E Linear Modelling. Graphs and equations can be used to model real-life situations. A graph allows a comparison between two variables. Straight line graphs can be used to model physical situations. The gradient and the intercept on the vertical axis of linear graphs have meaning in practical situations. Let's have a look at the first example. This graph models taxi charges. Part A. From the graph, find the cost of travelling 22 kilometres by taxi. So if we have a look along the bottom axis or the horizontal axis, we find where 22 kilometres is and we go up from there to where we meet the straight line. From there we go across to the vertical axis and that will tell us how much it costs. So we can see that it costs $60 to travel 22 kilometres. Part B. How far can a passenger travel for $30? This time we do the opposite. So we start on the vertical axis at $30 and we come across until we hit the red line. And then from there we go down until we hit the distance axis. And we can see that that is 10 kilometres. So a passenger can travel 10 kilometres for $30. Part C. Find the gradient. What is its meaning in this situation? So we need to find 2 points that we can use to do rise over run. So we can start at the point 2, 10 on the red line. And if we come across to 14 in distance, we can then go up to the red line at 40. So our rise over run will be 30. Our rise from 10 to 40 is 30. And our run is 12, which is from 2 to 14. So rise over run equals 30 over 12, which equals 2.5. Part D. Find the intercept on the vertical axis. What is its meaning in this situation? So we can see that it intersects the vertical axis at about 5. Okay, I've circled it there. Now the vertical axis intercept is the taxi fare flagfall. What that means is it's how much it costs for the taxi to come. The taxi hasn't gone anywhere yet, but it's a $5 before you even travel anywhere. Okay, so the vertical axis is how much it costs before you travel anywhere, and it's $5. Let's have a look at the second example. The interest, I, earned on a principal P for 1 year is given by the formula I equals KP, where K is a constant. If an investment of $6,000 earns interest of $300, find the value of the constant K. So we're told that I equals KP. We know I equals $300 because we're told that this interest earned is $300 and the amount invested was $6,000. So the principal was $6,000 or P equals $6,000. If we sub those in, we get 300 equals K times 6,000. From there, we will divide by 6,000 to get K on its own. And we get K equals 300 divided by 6,000. K equals 0.05. Part B. Use the value of K from Part A to complete the table. So if we're looking at the table, we're going to be using the formula I equals 0.05 P because we know K equals 0.05 from our calculations in Part A. So if P equals 2,000, we're going to have I equals 0.05 times 2,000. If you do that on your calculator, you'll get 100. For the second part, we'll do I equals 0.05 times 4,000, and if you do that on your calculator, you'll get 200. 6,000 is done for you. You should be starting to see a pattern now. Now we'll do 8,000. So I equals 0.05 times 8,000 equals 400. And for 10,000, I equals 0.05 times 10,000 equals 500. Now that we've completed the table, Part C asks us to draw a graph of this linear relationship. Here it is. Now remembering, a linear relationship is always a straight line. So if you graphed this and it wasn't a straight line, you've made an error somewhere. Okay, let's have a look. Part D, calculate the gradient of the line. So we pick a point that we can easily then count rise over run. So here I've picked 0 because this equation starts at 0. Now I can go across to 2, so that's going to be my run is 0 to 2, and my rise is going to be from 0 to 100. So for part D, gradient or M will equal rise over run, which equals 100, because my rise is 100, over 2,000, because my run is, yes, 0 to 2, but as you can see, the principal is in the thousands, so it's over 2,000, and that equals 0.05. Now you should see here that the gradient M also equals what K equaled. Okay, it's because the relationship between principal and interest is a linear relationship. So like we spoke about in 12D, K is like the gradient. Okay, the formula y equals kx is the same as y equals mx. And the meaning of this gradient is the gradient is the rate of interest being earned on the investment. So 5% of interest is earned on this investment. Let's have a look at this example. At an athletics carnival, Celine runs 100 metres in 16 seconds. It is assumed that she runs at a constant rate. So we know this is going to be a linear relationship because the word constant rate is there. Draw a straight line graph to model Celine's run. If we have a look at this graph, we can see that the point that we were told in the question was 100 metres in 16 seconds. If you put that point on this graph and then draw a straight line straight back to 0, because when she runs 0 metres, it's 0 time, okay? So we have a straight line going from 0 all the way up to where she runs 100 metres at 16 seconds. Part B is find the gradient of the graph from part A. As we can see, if we go from 0 all the way across to 16, that will be our run of 16 units. And if we go up to where we meet the red line, that will be 100. So our rise will be 100 and our run will be 16. So the gradient, or M, will equal rise over run equals 100 over 16, which equals 6.25. Now, as we said before, M can also equal K. So, part C, write an equation to model the relationship between distance and time for Selena's run. Which variable is the independent and dependent variable? Which one depends on the other? The distance depends on the time, okay? Because however long we run for will determine how far we run. If we run for 16 seconds, we're going to run 100 metres. If we run for 8 seconds, we're going to run 50 metres. Okay, so our dependent variable is distance, and we're going to call that D. Our independent variable is time, okay, and we're going to call that t. So if we remember our formula, y equals kx, k is also equal to m, so k is going to equal 6.25, and our y, which is our dependent variable, is going to equal d, and our x, which is our independent variable, is going to equal t. So our equation to model the relationship between distance and time for Selena's run is D equals 6.25 t.